Okay, here we have Chris's Ford Ranger 1999 with a 3.0 liter flex fuel motor in it. The problem has been no AC. Now it does have a slow leak, so we thought that the problem was just low on 134A. So I recharged it. It worked for about one cycle, and then that was it. So what we found was that the compressor clutch, which is there, was not staying on. It would cut in for a second and then go off. So we started trying to diagnose what was going on. I thought maybe the clutch was failing since it would cut in and out. So the tolerance here, they call this the air gap, is actually too wide on this particular unit, either because it was set wrong or it's just worn out since it's 2014 and this is a 1999 with about 180,000 miles. But before I ripped into that, I did a little bit of diagnostic work. First thing I did was I went up to the relay box and changed or swapped two of the relays, the AC with another one, to see if that was causing the problem. Our friends at Ford do not tell you what relay is what in the top of this container here, so you have to look in your owner's manual to figure out their little code as to which relay is what. I believe it was this one or this one, so these were the ones I swapped. That didn't make any improvement. I probed for electric here, which would tell me in this wiring harness, which would tell me whether I had 12 volts going to this, and I only had it intermittently. So then I started thinking what else could be causing that, and I thought, well, maybe one of the limit switches were bad. So this is the high pressure limit switch. So I disconnected that, probed it for electricity, and I had a solid 12 volts going into that. So I rehooked that. This is the low pressure side limit switch. So I probed that, thinking maybe that was cutting in and out. That was not. I jumpered this one with a paper clip. That made no difference. I jumpered this one with a paper clip, and that made no difference. And then it dawned on us that we had a check engine light. So I probed the motor, and it was code P0118, which is a coolant temperature sensor. And you could see the brandy new one down in there. This is on the top of the motor. You see this is the coolant coming into the thermostat area there, and this is right next door with a 2-wire connection on it. There's a lot of information on how to test that circuit, but basically this probe was telling this motor that it was minus 40 degrees motor temperature, because when it failed to that. That's how, one of the ways it fails. This is the sensor. So what we reason is that the sensor through the ECM was basically cutting off the power to the AC clutch. So what we did was put in a new sensor, hooked it up, turned on the AC, and everything seems to be working just fine now. So if you have a P0118 code and you're getting an intermittent clutch operation, you have to fix that problem, because I think that's a good part of why this thing is cutting in and out. So it stands to reason, because the ECM thinks it's minus 40 degrees, it's going to tell the motor, worry about getting yourself started in 40 degrees and don't worry about turning on the AC and putting more drain on the horsepower, just worry about getting started and getting going, and then we'll turn the AC on later. And I think the AC does a little 2-second self-check at the beginning. So when you start the motor to begin with, you'll see this clutch turns on for 1 or 2 seconds and then shuts off. I think that's like a self-check to let the computer know that the clutch is operational, so you don't get a code for that. And then it turns it back on when it determines that everything else is good enough to support the air conditioning unit, the extra horsepower draw, that 2 or 3 horsepower that gives. So that's my theory, and that's how we fix this motor, and now Chris has nice cold air conditioning again. So thanks for watching. Bye.